services together. And then Sunday afternoon, what's happened since I last saw y'all, I am now taking a cyber security operations course from Cisco to be an instructor of it. And they've got 3 of them. When y'all go into Netacad, you can actually see the first 2, and y'all can actually self-enroll in the first 2 of them. They've got a Cybersecurity Essentials and an Introduction to Cybersecurity, and y'all can actually do those self-enrolling to them. Okay? And if you finish them completely, they'll give you a certificate just like y'all got from me last semester in here. Okay? One of them, the first one's a 15-hour course according to them, the second one's a 30-hour course. I have not done the second one. I'm enrolled in it by Cisco because of a seminar I listened to about it back at the beginning of May, and they enrolled me into the second one, which I believe is Introduction to Cybersecurity. I think Essentials comes first and Introduction second, or maybe opposite. And then they got a third one, but that one has to be taught by an approved trainer. So I actually paid to take that from the group in North Carolina that I've done stuff with. And so I'm taking that class online now, which is 13 chapters long. And it's supposed to end early in August, but I can run later in it. The guy reminded us that at the first session, because we're all in it to teach the class, and we're all teachers, basically, taking it. And they charged me like $185 to take it, which isn't a bad price, really. Because actually, some of the places used to charge, when I took my classes y'all are taking, the teacher ones, and had to go to West Virginia University, they charged a whole lot more. We were paying $350, $500 a week for each one of those classes for me. So $185 is not too bad. So Sunday, I spent all Sunday afternoon doing Unit 1, which is not due. The only thing that was due yesterday was introductions, which I did last Thursday when I got in the class. I introduced myself, and we don't have to do, and that's all I have to do about discussions in there. It's not like here. And then chapter 1 is actually due next Sunday. I've got that all done, did the first test, got it done, did good on it. And 5 assignments, I think it was, I had to do, and caught 1 error on the test and 2 errors in the curriculum in chapter 1, which I pointed out to the instructor, and he said, send it on to Cisco. So I'm an instructor for him. I can write to send about whichever thing I want. So I reported that to them, that they had mistakes. On the test, a certification that CompTIA does, they referenced it on there, the CSA Plus, that you may know about. Certified. Years. The CSA Plus, CompTIA has had to change the name because CSA is used by some other organizations, a trademarked acronym, and they got in trouble about that, so they've changed the name of it to CYSA Plus now, a lowercase y stuck in it. And I don't even remember what the Y stands for, but they came up with something. And this brand new curriculum still is referencing the old name. Okay. You know, they need to have it current. And then they had about DOS being created by Microsoft. And I said, no, that's not correct. DOS was created by Seattle Computer, actually bought by Microsoft, and then leased out to the original IBM PC6. But Bill Gates and Paul Allen did not, and their 4 colleagues, or whatever it was, And most of y'all have seen the picture of them from back then, where it was about 6 of them in the picture. You know, it was like 2 women and the 4 men or something in the picture. And it was owned by Paul and Bill. Just a little tiny company. And that IBM came to them about an operating system and wanted a disk operating system, and they said, described what they thought was a neat one, and IBM said, yeah, they wanted to get it, and it was realized within the group that they didn't even own this thing, that they had just agreed to sell copies of to IBM for a large amount of money, so they ran down the street and bought it from this other company. And they did pay that company a good bit of money later on as a goodwill thing, a few years later after they'd made tons of money. But Cisco said it was created by them. It was developed by them, because yeah, they went on and did some more stuff with it, but they did not create that operating system. So now I'm doing the next chapter and trying to get through it and working through it. So now tonight, and if any of y'all did not get the test taken for 2 yesterday, that was due yesterday, and then 3 is actually due next Monday, remember? But yesterday, I don't know if y'all had done it in advance or not, but Cisco had problems with the site yesterday. And I don't know for how long, because I didn't check back into it, but none of their tests were working yesterday morning, and they didn't know how long it was going to take them to recover, so I put out the note that said I was extending the test on it. Well, apparently nobody tried to take it then last night, or today, because nobody had written me and pointed out that I didn't extend it, because I was actually sitting down in Calhoun in a meeting this afternoon. I went, whoa, when it hit me that I never had gone back in last night and activated it first day. So it is activated out there now through tonight if any of you did happen to not get Chapter 2 test done. Okay? I didn't go in and look to see who all did or whatever. Everybody may have gotten it done through yesterday, and I may not have had to go in and activate tonight. I don't know, but I wasn't going to go look in there and dig down and try to figure that one out. I just activated it to make sure. So tonight, we've got class tonight. We've got class next Tuesday night, but then the following Tuesday night, the 19th, we won't have class. Okay? So I'll be in Jacksonville that week. But then we'll have class the following week, and then that'll be it. Other than I'm trying to still figure out how I'm going to do y'all's final exam. As far as you coming in, because y'all need to come in and do the cabling on the boxes in here. You can do the configurations on Packet Tracer and stuff, but Cisco wants you to actually wire the boxes. And so between the 2 classes, I need to try to figure out some way to do that. That might be the beginning of August before y'all do that. Okay? And I'll give y'all a gap of time once I figure it out. And it may be that I'll make it available for y'all to do. No, because that won't work because I'm coming back Thursday. So looks like the beginning of August. And this semester really doesn't end until somewhere there in the beginning of August. Y'all's class actually ends back on July the 17th. This is the last day supposed to be the last day of class. And then the final right after that. But there's still 2 more weeks after that that are in and before I have to turn in grades. Or we may not wire the actual boxes this semester. Trying to figure out how to do that, but I haven't figured that one out yet since My original plans was the second week of July we would do that. Until they stuck me into, well, I got to go to Ohio for a conference for 4 days. So, chapter 4, which is where we're at, gets into a whole nother stuff. Really gets into the switching and the switch networks. And goes through and talks about a lot of terms on that. And then 5 goes into the configuration of the switches, which you have actually already done, if you remember, from last semester all the way back to chapter 2. Okay? Because that's what they had you doing last semester, was working with the switches. So really, 5 isn't going to be that much to you. There'll be some extra stuff into there, but they're going to teach you some more on it. But you're basically doing the type stuff you did along back there. So everybody follow with that part? So it's not, you're not diving new. 6 we're going to get, 6 really isn't totally new either, because actually they had you use a VLAN back there in the other book also. So we're going to talk more about it. Now, so in the chapter in 4, which is really a short chapter, because it's only about 20 pages long, that they throw you some different things, and a few of these things we really talked about before. And I really don't think that even, I guess it is 20 pages long, but it sure doesn't even seem that long. The very first thing we've talked about, I've thrown out to you the term of convergence, and that you want to get your networks into a state of convergence. Well, here's where they're going to confuse you, because I've told you the state of convergence is where everything knows about everything else on your network. Does everybody agree on that part? Okay. Now they're going to throw in, and I don't know why it was decided to use a similar term of the same term, slightly different of the term, just a different case of it, to mean something different. Okay? So remember on the convergence, it's sort of like where I mentioned to you about routing and routed protocols, and you're going to have to learn those too as you go along the way. He can probably tell you which ones are which right now, if we prod it back in his gray matter deep enough. But with convergence is that state that you're trying to get to. But here they're going to talk about converged networks. Okay? And a converged network is where it's a network, and most of your networks nowadays are actually converged networks. With what Jeffrey works with over there with the telephone company is they're very much converged networks. That's why they're into networking now. Okay, is that all have converged several things. So with a converged network, you're actually using the network to do multiple things. Because whereas before the networks were purely just data networks, and that's all you had the network there for, was to share data. Now you're combining them together. So we'll go back to Jeffrey as my example right here. You had telephone was one totally different network ran out there. They ran their own wires for everything, and coming in the building, it was their own wires sitting all through the place. And then if you had a computer network, it was a completely different set of wires, and everything was two totally different worlds. Does everybody follow on that? And you've got that still in some places. Okay? But to take here the school as an example. The school here's got a converged network on it now. Okay? So that we've got the telephone and the data network are the same network, because we're doing voice over IP here. And I'm sure he's seeing more and more of that, of what they're doing of the telephone company, that it's across data networks now, not doing voice over IP versus regular old, plain old telephone service, POTS, or what's the other term for it? Huh?
POTS and DSL is what we got.
But you've got POTS and you've got another acronym that references just regular plain dial telephones, all that can be push buttons, etc. now, okay? But where it's just the regular old wired system of everything hooking together. Now, you've got voice over IP in a lot of situations. You're carrying the data on the same network. You're running cable TV across that same network, so all your channels are coming across the same network together on that. So that's a converged network when you've got several different, what used to be independent networks, built into one network carrying multiple purposes. So do you follow on that? So a converged one is where it's doing several different, what used to be separate things, and in some cases still is separate things, okay? Depending on where you're at, etc. Because we can still look around and we obviously, telephone still runs as a separate network out there, but it can be converged in with our data networks and doing all of that together at the same time, and it's done sometimes out there on a bigger level, but in some cases it's still sitting there separate, etc. Or within an organization, you may still have just a data network in there completely separate from your telephone stuff. Or you can have it converged, like we've got here, where the telephone and the data is all running together. Or at my house, that it's a converged network there, because my network with my computers is right there on the same thing with what Comcast is pumping in there for my TV, for me to watch the TV on it, so that my cable's coming across the same wire and the same split, and it sort of splits out. So it is a little bit split once it gets in there, but it's all commonality in the first place.
Is that what the VLANs allow you to do? So I think our internet's on VLAN video.
The VLAN is going to give you some secure connections and going to let you build your own connection across a bigger network where you've got your own private network on top of a public network.
Yeah.
So that, like, if I want to connect, you and I want to connect between our two computers,
Yeah.
but we don't want Kendall and Aaron to be able to know what we've just exchanged across that connection. We'll set a VLAN between you and me. It's going to go across the public network, but it's a private network running across there, and it's encrypted, and it's so that they can't steal our signal and see what in the world you and I are talking about, and that Kendall and I can set up our own separate VLAN, and that you don't know what Kendall and I are passing information back and forth on. Does that make sense now? But we're doing it across the internet. We're not setting our own connection from my location to her location, or my location to your location. We're using the internet as our backbone. And we don't have to worry about all that equipment between the locations. Now, like in school here, we're not doing between campuses connection through VLANs. We've actually got a physical fiber wire running from here down to Rome, and a physical fiber wire running from here over to Ringgold and down to Dalton. I don't know which way they are. Probably from here to Ringgold and from here to Dalton, since those are newer locations on us. And then we get tossed in there, Gordon gets tossed in there somehow, and it's a connection from somewhere, probably from Rome to Calhoun. You know, we've got actual physical fiber wires just for us to use between those locations. And then we have connection out into the internet from there. But we don't, in a lot of other organizations, you set up a VLAN between these two, between each of the campuses, and just connect out to the internet and use the internet. keep your connection across and not put your own equipment from one place to the other. And I've done that for some small office places that were multiple towns. Instead of up a VLAN on it, and they just use their internet connection and use the internet connect across. But by using the VLAN, both locations, it looks like they're both at the same place, because the connection then appears that the one at the other end is actually sitting physically in the same location as they are, because it looks like it's the network when we look at the network here on campus. Does that answer the question? And we're really in chapter 5 goes into all of that. No, chapter 6, sorry. So with the converged one, it's just getting all that complexity all built into one network instead of having multiple networks on it. And they throw some different things that can involve there. And then they talk about the Cisco borderless network, and that's where your network's not just defined into a location, but it spreads all over the place, and anybody anywhere can be attaching into your network, and they're right there original on what used to be a physical one location network, but it's really spread out, could be spread out all over the world. Just like everybody getting on the blackboard. That network off of that is scattered everywhere in the world, and that we can go connect through the internet as our way on it back to just into that specific small network in Indiana, or might be in Florida. I don't remember where Blackboard is. Angel was in Indiana, and I don't remember where Blackboard's actually sitting their stuff mainly from. So that's what the borderless one gets into, and you're using switches to connect all together and control all kinds of things in there. They talk about access layers, distribution layers, and core layers in here. So that when you're looking at your network, there's really 3 different levels within that network of where stuff is occurring at. The access level is the part of the network that usually most people think about between the access and the core levels. That the access level is actually the part of the network where the network's connecting to all of our different local devices. So when we're sitting in here thinking in terms of in this room, it's the connections that we've got of these PCs back to the switch. That it's all of the local devices makes up the access layer. That's where people access the network. Okay, so that's why it's the access layer. The distribution layer, let's come back to in a second. Let's go to the core layer. This distribution layer falls sort of in the middle. So let's talk about the other layer. So to a degree, the access is up there, and it's where everybody can get to it. The core layer is where we're connecting to the other networks out there and connecting to the world. Okay? So your devices that connect your networks together and connecting out to the internet is going to be the core layer. Does everybody follow on that? So that's that root level on it, and people can picture that one because you know there's equipment out there that just connects the internet all together, and that's getting into the core level, and it's the routers connecting them all together. So you're really looking at here, you're connecting the networks to the networks, okay, but you're only looking at how the network connects to the network. You're not at all concerned about the users on it. So, and that's a lot of what you're looking at in terms of what you're learning here in Cisco. The people that learn the Windows stuff are really working more at the access level, okay? and on the distribution layer. The distribution layer is going to be within your network of the devices to connect everything together on the access layer and connecting back to the core level. That's where your switches are going to be located in your network. Okay? That's where your wiring closets are going to be also. So where all of the wires from all of these machines come together is going to be on the distribution layer. It's distributing our networking capabilities out to the individual machines. It's also distributing what they're wanting to get to transmit to the rest of the world onto the internet. But it's not actually putting it on the internet, it's getting it to those devices that do put it to the internet. Do y'all follow? Access versus distribution versus core level. So the core level is when you're looking at really connecting it to the world and actually connecting the networks together with them. Because if you look here at the school, you've got a network here in this building, probably a couple of networks in this building. And then they connect with the networks in the other buildings. Well, where you've got it in the building going to the user, that's access layer. Where you're connecting them all together within the college is distribution. Okay? And where we connect on and get all of those networks actually connected together and go out into the world, we're looking at the core level. So the core level is really reaching to the outside more of. Distribution is how are we distributing it within our organization. And that's where your switches and some of your routers are going to fall. But your biggest routers are going to really fall back up there on the core level. And then the access level is your end user devices. And that you've got your switches that are connecting that together. And in the old days you had hubs sitting there connecting them together. But that's where you're just connecting all those local devices together, but not further than that. And PSTN was the other acronym I was trying to come up with for the telephone service a moment ago. Kind of flip the page and see the PSTN there. So you'll see, as far as connecting to the telephone network, you'll see them refer to it sometimes as POTS, plain old telephone service, or PSTN, which is plain switch telephone network, I think it is. Okay, but they're both the same thing. It's where it's just the telephone service of what the telephone company would provide for you as a traditional service. Okay, and to be doing telephone type stuff. And DSL sort of falls into that one. Versus where they talk about the WAN right there, you're really talking there in terms of more doing the fiber and that type connections out there, the higher speed internet connections, and could be the T1, T2, 3s, etc. Does that make some sense to all of y'all? Okay. Then they talk about switched networks and about developing your networks using switches in there. They give you some ideas on that quality of service is an important part. And keep in mind, we're now, everybody's using switches now. But a few years ago, that you used to be, if you go back 10 years ago or more, you had hubs there instead of switches. And that hubs literally just were like where you just ran wires together and just connected all the wires, but you had a nice little box there that was the connector part of it instead of having wires all on it. So that right there is a hub. And there's a stack of them sitting back here. You don't want to use hubs anymore. So everything's gone to switches now. If by chance y'all do come across a network that's still got hubs in it for their networking portion, first thing you want to do is get them to let you go buy a switch to replace their hub with. and then you're going to look like a wonderful hero to them at that point, because their network is going to increase in speed tremendously, because it's going to start running at the speed they thought it should have been running at all along. Okay, because with the hub, it split the speed of whatever the speed of the network was by the number of devices that was on there. So if you did have a 100 megabit network and you used a hub for 10 devices hooked together, the effective speed for each machine was only 10 megabits. Okay? A switch, so a hub's a dumb device. It's just a way to connect the wiring all together nicer. The switch is an intelligent device. It does the same thing as a hub as far as that basic capability. It connects them all together. And when you just look at them, you're not going to be able to tell a difference, because there's a switch for you. It's got a whole bunch of connections also, just like that hub did. The only difference is this one says switch on it, and that one says hub, and there's a whole lot more stuff inside this box. And that this box costs a whole lot more than that box. Okay? Now, we can go to other parts of the world and still find some places still using lots of hubs sitting there. Okay? But with the switch, what happens is, instead of on the hub, if Aaron sent out a message to go to Kendall, it would go to all 5 of our machines, all 4 of us, but other than him, okay? All of us machines would actually see that message come across. Y'all follow on that? Now, Kendall's machine would be the only one that would know, sit there and go, oh, it belongs to me, and then display to her what the message was. Our machines would look at it and go, nope, don't belong to me, and just ignore it. Okay? The switch, Aaron sends the message, it goes to the switch. The switch looks at it and says, oh, that belongs to Kendall, and sends it out on her wire and does not send it out on the 3 of our wires. Y'all follow on that? So guess what? It becomes a whole lot faster then, and effectively you're going to get full speed on there. So if we had that 100 megabit connection network again, and there were 10 of us sharing it, we're going to effectively have 100 megabit service to each machine. Now, in actuality, it'll be a little bit slower because it is sitting there and thinking on that before it decides what gets sent to each spot. It does slow down a little bit, so you're really probably going to get 95 megabits. But think about it, 95 versus 10, you're getting a whole lot faster. Y'all see on that? So it sits there and decides who gets what. So with the switch network, it's just a way of connecting them all together, but it also is the intelligence where the only stuff that goes on any part of the switch network is what belongs there. Okay? Now, there are times that it does go to everybody. When we first turn all the equipment on, and before the switch knows who's sitting on what port, the first things are going to go out all the ports of it very initially starting, but as soon as something comes in from each port, it knows who's on that port. And then from that point on, it only sends to that port what belongs on that port. Does everybody follow on that? So initially, if you turn your computer network on every morning, that you come in and turn on all the devices on it and switch on at that point and turn on those devices, yeah, the first couple of times as you first initially start up, it's going to be sluggish, but you probably won't realize that because your machine's still coming up on you anyway. And then as it learns, it speeds right up to full speed. But not to tell you that it is going to be all there from the very beginning. They give you some different objects about on what you want to consider as you consider your switch network and what switches you're going to put in there. Cost is a factor. Port density, what that's telling you is how many devices will it support on the network. Power, do you want it, that switch, to actually be supplying power to your devices? Didn't used to really do that, but now it does. Okay, and remember it can also actually, which is the freaky one to me still, is you can actually power devices wirelessly too, which is a little strange to me. But it's where it's real low power usage, Internet of Things devices and stuff, that they can actually pull their power being transmitted across on a wireless signal. And that's still strange to me. But you can definitely power devices across the wired network, but now you can actually start doing it wireless too. Reliability is a factor of that. Depending on your network, you want higher reliability. To throw you a number that could pop up at some point on you, because I've seen them mention it before in these books, and it gets mentioned more and more, and they've thrown it at me several times in that class I'm taking now and the previous one, is on reliability, that if you say that something's got 99.999% uptime reliability on it, how many minutes a year is that saying it could be down at most to be 99.99959's reliability? Anybody know?
No, I can't remember.
Jeffrey, you know? Aaron or Kendall? Means you can be down 5 minutes out of the year to have 99.999% reliability. Which, if you think about it, you see ads for stuff saying they're 5.9 reliable or that 99.9999 on it. Okay? It's really 5.5 minutes and 43 seconds, I think it is, but it's 5 minutes is what most of the time they'll say. Okay? Is the total amount of time that network can be down in the year. That's not much. Okay? And then some of them talk about 7 nines, and that gets down to less than a minute down per year. But the 5 nines is the one I've seen most often referenced, and so I'm getting that one on into my head to remember it's 5 minutes with 5 nines is all the downage you can have in a year. It's not said to here right here in the book, but it may come up in this course, but it comes up in one of our 4 Cisco courses anyway, slightly on it. And that's going to be something that's going to be thrown more and more at you. Port speed, how fast is your connections? Obviously, that could be, your devices are generally going to run at 10 megabits, 100 megabits, or 1,000 or gig speed. Nowadays, you want to be looking, probably getting at more of the gig speed ones, but for sure at least the 100 megabits for your internal network, okay? But they will work back with the 10 stuff if you happen to have some of that stuff sitting around. And remember, the nice part on Ethernet is every part of the network runs at the fastest that it can possibly run, versus token ring, if you remember, whatever was the slowest device on your network, that's the fastest you could get the whole network to run, okay? So if you did still have an old piece of equipment on there, it won't kill everything else, it just kills that one connection. Frame buffers, that gets back to, remember we talked about fast forwarding and storing forward and stuff on frames? That gets into that part. How much does it need to buffer before it can be sending it on out? And the scalability is the ability to add more users on our network, designing a network that we can grow it. And when they're saying users there, that could be in terms of humans, that could be really counting devices. So that right now Aaron would count as 2 users onto a network because he's using his phone and using the computer at the same time. So you're 2 people now, Aaron, not 1 person. Okay? So when they're saying users, quite often you're really thinking in terms of devices, not people. Okay? Does everybody follow on that? Because most of the time we're all counting nowadays. You go back not that long ago, we all count at one time, but now most of us are connecting in multiple ways at one time. Okay? So that I can be sitting down there in the office and I really count as 3 users a lot of the time. That I might be on the phone talking to somebody while I'm doing something on the computer and actually have my phone out doing something at the same time and be doing 3 things on the network all at one time. Fixed configuration switches, would-be switches, and we've got some in here both ways. Yeah, we actually got router that is flexible. But that one's fixed. Everything's already built in there and we really can't change it. Okay? If we look at this router, and you can get switches the same way, well, they will come apart. Notice on this one, it's configurable. We can replace right there with different type interfaces plugged into this router. So we can pull that. Yep, I heard it beep. So that we can pull these different interfaces right here and stick different interfaces in there. This one's blank right now, but this one's got a serial connection sitting there, and we could change that and go put a fiber one sitting in here, and all we had to do is just change that connection right there. So where they're talking about the 2 different ones, that's what they're talking in. Now, agreed, I just showed you a router and a switch, but you could get routers or switches both ways. I'll follow along on that approach there. So that when they talked about the modular configuration switches, that would be like that router I just showed you, where you can change stuff in it. You haven't bought a switch that you can only do what it's got there, and if you need something different, you got to go buy another switch. You can just go buy another component to plug into it. Which is the direction to go with it, and to give you that more scalability also to it. Okay? So then they talk about the frame forwarding and about it coming in and then it going out, and it finding which port it belongs on, which I sort of described to you already. The ingress port is the port it comes in on. The destination one's one obviously it goes out on, but ingress may be a different term for you on that one instead of just the input port or whatever, or the source port. And public switch telephone network was what PSTN stands for. I like where you turn several more pages and then they tell you what the acronym was they used several pages back. Instead of telling you about it when they first throw you the acronym and you're sitting there going, what is this acronym? And then they talk about the MAC table, that's going to be, the MAC table is normally going to be a dynamic one these days, but it could be static entries in it too. And that's where the switch keeps track of what the MAC addresses are of all the devices connected to it. And that's how it decides what goes out which port. Okay, and remember the switch is working on layer 2, working with frames, and what are the addresses on frames? It's the MAC addresses, the physical address. Layer 3, where we got the routers, works with the IP addresses and with those on it, okay? So all of that stuff I taught you last semester still counts. I know several of y'all wanted to just figure you could erase that all out and start new again this time. And when I'm getting into the class I'm taking right now, it builds on some of this stuff. They talk about the forwarding methods. So they talk about store and forward. Remember, store and forward says the whole frame comes in, it looks at it, and then it ships it out. But you get the entire frame first. Cut through switching, it brings in the very first part of the frame, which has got the addresses on it, remember? And all it needs is the destination address, which is actually the first piece of information on that frame. It looks at that address and starts sending it on out to the correct port it belongs on. as it's still coming into the switch. Now remember the limitation on cut-through forwarding. That means runts and giants, which are pieces of frames and ones that got extra stuff that has gotten accumulated on them somehow, all get forwarded straight on out. Okay? Store and forward, runts and giants die, because the whole frame comes in and looks at it and go, whoa, this is a bad frame, because it looks actually at the CRC, the cyclical. I can't remember what the RC stands for. But where it uses that check number to look at it and says, wait a minute, it's not right here. But cut-through forwarding is going to be faster than store and forward, so most of the time you're using cut-through. Error checking, they mentioned uses frame check sequence on the switch, which is working like the CRC that we've also mentioned about, where it looks at the whole value of it and then creates a number from that. So it goes through and creates a number off of it of what the whole value is, sticks it on there. When it arrives to the destination, it does the same calculation again and sees, does the number match? If it does, it can figure what was sent is what actually arrived. Collision domains they talk about, and broadcast domains. You really don't have collision domains so much anymore, because using switches, your collision domains really have died. The collision domain is where it's all the traffic is shared on the same wire, and you had collisions occurring on there because they were all sharing on there. Think about what I described the switch to you a moment ago versus the hub. The switch, the only stuff that comes to Aaron's computer is just traffic belongs to his computer. Guess what? That is his collision domain he's on. It's just between his machine and the switch. Now, how many collisions are really going to occur on there? Shouldn't be any, because the only traffic on it is what Aaron's sending to the switch and what the switch is sending to Aaron that belongs to Aaron. Might still be a collision, but it's going to be extremely rare. Whereas before, everything went to everybody and we were all going across the same wire all together, so we had lots of collisions occurring. Does everybody follow on that? So you've reduced your collision domain down to just two machines, so you effectively killed the collision domain. Broadcast domains is actually working on the layer 3, but with the broadcast domain is what that's saying is, if we send out a broadcast, which is a message to every machine in the connected area we are, and we could still send to our whole subnet, okay, send a broadcast out to it. What are all of the machines that are in that domain which are actually sitting on the same subnet with us? Okay? It's not a collision type thing at all. It's what machines all get something that's sent out to everybody. Used to be originally on the internet, your broadcast domain was the entire world. And so we started putting up firewalls and everything in there, separating off our networks, and so then messages literally didn't go to every machine in the world. But back there in the early 90s, I could put a broadcast out when I was sitting there running the network at Swainsboro Tech. I could do a broadcast right there that went out to every machine in the world. That came to a rapid end when the internet started growing. But when it was still just a small thing throughout the world, it was actually happened on it, and that people would actually do it. And then that's where your earliest spam stuff was done on, was done using that, and that was real quick going. People were going crazy because you'd send out commercial little boxes of whatever spam you wanted to send out. So we figured out other ways people figured out to do all of their spamming, etc. out there, because then you just put a firewall up there and that breaks you off onto a separate broadcast domain. But it was one big broadcast domain. Um, and then they throw you a few little notes at the end about how you can reduce the network congestion. High port density, and that's with having more ports on your switch, so that instead of having a number of devices coming off one port, which you did have in a lot of cases early on with switches, that you'd have a switch and then you had hubs hanging off of the switch, and then you got switch and you got switches hanging from the switch. And so you've gotten it all broken down. Changing your buffers to the different sizes, port speed, speeding them all up, and like I already mentioned in here, it used to be 10 megabits, then it went to 100, and in a lot of cases you're doing it 1,000, or you'll see the 1,000 as a gig. Okay? Questions on that? Because that is chapter 4. As I said, that chapter suddenly looked pretty short to me when I was just looking at it just now. That's the one that's due next Monday. Okay? Along with, if you didn't do chapter 3 yet, it's due next Monday. But remember, I opened up 3 last week for you, where you could go ahead and do it without waiting until next week if you want it. Again, I haven't gone out and looked to see. I don't think I've transferred any of y'all's grades yet. I've still got to fix the grade book actually up, and I just haven't had a chance to do that. I'm still trying to. 2 of my classes are not fully set up. I've got them pretty much there. I've got to get them finished set up before I'm going to fool with grade book stuff. And transferring grades, that would be something fairly easy for me to do sitting in the motel at night. I'm trying to do the things that I might need to interact some more real quick here. Questions on all of that? And if y'all did notice last week, I did put last week's lectures out there in the 2 chapters. I don't know if y'all noticed that or not. I'll do the same thing this week, except now, since I goofed up back there and apparently pushed the stop button with the switch when I was holding it, I'll have to combine it and then break it in 2 to split the 2 chapters into separate lectures. And somebody's phone just beeped.